In section 8.2, number 1, 8.2, we're talking about ellipses and hyperbolas. Now, for number 1, you have to find the graph of the ellipse, find the domain, the range, and the foci. Okay, so what we have here is x squared over 25 plus y squared over 16 equals 1. Now, I already wrote the two general equations for the ellipses down right here. If the major axis is on the x-axis, then we use the top one. If the major axis is on the y-axis, and then we use the second one. Now, this is for all a's greater than b, and of course they have to be greater than 0. They can't be negative. Okay, so let's take a look. We have 25 here, and 25 we can clearly see is greater than 25. Let me write down. 25 is greater than 16. So we're going with the top one. A is greater than b. That means a squared is 25 and a is equal to 5. If you are taking the square root, we can also find b. B squared is 16. That means b is equal to 4. Okay, so we have a and b. Now, the center of this ellipse, if you're looking for h and k, we don't have any parentheses in the numerator, so the center here is at 0, 0. That is your center. And one more time, we're using the top one because if a is the denominator of x squared, which we have here, then the major axis is the x-axis. And if the variable a is in the denominator of y squared, then the major axis is the y-axis. So in our case here, we're looking at the top equation that also makes this ellipse to be an horizontal ellipse, just like that, compared to a vertical ellipse, which would like this. So here, this is the top one is horizontal, and the bottom one is a vertical ellipse. If the major axis is on the x-axis, if I draw a little, there you go, then you can clearly see it's a horizontal ellipse. Okay, what else do we need? The vertices of this ellipse, let me write it. The vertices are at plus minus a comma 0. So in this case, we have vertices at negative 5 comma 0 and at 5 comma 0. And the endpoints on the minor axis, which would be the y-axis right here, the vertices are at 0 comma plus minus b, so that would be 0 comma negative 4 and 0 comma positive 4. Okay, we also have to find the foci. The foci, if the ellipse is horizontal, is on your horizontal axis somewhere here and somewhere there. Now, to find the foci, we're using the knowledge, what we know about the Pythagorean theorem. C squared equals a squared minus b squared. The foci points are on the x-axis, so they would be whatever c is plus minus c comma 0. So to find z, I can squeeze that in here. We have a squared, which is 25, minus 16, that's equal to 9. So c in this case is equal to 3, which means your foci points on this ellipse are at negative 3 comma 0 and at positive 3 comma 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4. 1, 2, 3, negative 4. Now we can plot this beautiful ellipse, and that's almost, here you go, almost actually like a circle. But here is your ellipse. Now you also have to find the domain and the range. The domain in this case would go from negative excuse me, negative 5 to 5, and the range, your y value, so your lowest y value is negative 4 and it stops at positive 4. Here you go. That is your ellipse.